No, in a different lighting setup, that'd be a cushion. But in this kind of lighting
All right, we're
setup,
back. Oh,
and
damn
we were
thing. Um, I need to share it. And my link that, and then share screen. Sure. I'm back finally. It said 7 minutes, but then it took 9. So apparently Zoom can't count time, which is very impressive. Good servers, bro. I'm very impressed. All right. Anyway, so we were talking about slicing. I think we talked about it, and now we're gonna finish talking about tuples. So it talks some stuff about tuples, performance, values. Da-da. Yeah, that's a tuple. Yeah. So they talk about that. So if you want to return multiple values, so if you do, so if I have my thing here, so if I remove this, but if I have my return thing here, and I want to return the previous bank and the credit score. So I have something equaling it here. So I have it here, right? So maybe I'd have maybe this would be equal to something. I don't know, it'd be equal to A. I don't know. But this would be a tuple. So yeah, this isn't I don't think this is hugely important. I mean, it's good to know. It's really important to know if you for example, if you want to do something to it. But yeah, this will be a tuple. I believe you can just have it do like this, like B. I believe you can do this as well, and it won't be a tuple. It'll just be two objects. I'm not sure off the top of my head, but I don't feel like you don't normally need to. Excuse me. No. Oh, allergies are killing me. I don't believe we're going to need to return two values, but just in case you do, you can. And then when you want to access them, it'll just be the value you returned it to, 0 or 1. You just won't be able to change it. But you don't usually want to change return values. You usually want to, if you're returning two values, you usually want to then put it into a different variable. So that's not, I don't think it's a huge issue. Yeah, but list or tuple, it's really just, do you want to change it often? List. If you don't want to change it often, tuple. And it doesn't really, you can use either. You can use either for anything you want. They function in basically the exact same way. It's just a little bit more complicated to change tuples, but they function the same. And if you want to change one to the other, you just do this. So all of these, with the exception of dictionaries, that's another thing. Well, actually, I'm gonna say semi-convertible. I don't know if you can convert from sets. I'm not sure about sets, but convertible means if I have a tuple, I have my tuple here, right? So I have my tuple. It's equal to this. And I want to change it to a list. I can just do this. And now, and I'll have it equal to list A. This list A will now be a list. It will be a list with all the exact same properties of the tuple, except it's now a list instead of being a tuple. So you can do that with tuples. You can do it with lists. I think you can do it with sets. I'm not sure, but I'm pretty sure you can. You can do it from dictionaries. So if you do list and then you put a dictionary in, it will give you all the keys, if I remember correctly. But I'm not sure if you can go to dictionary. You might be able to, but I don't know. You're not going to want to do that. You're not going to want to convert directly to dictionaries. I don't think that's a good idea. I don't think that's the play. And sets are special in that they're the only one that's both not ordered and not indexable. If you want to access what's inside of a set, you're either going to have to print it or you're going to have to put a for loop to go through it. So we can go here and we can say set equals, and it's going to be curly braces. And when you initialize it, so you initialize it, but then she has just said circles for it, and that's a really good way of explaining it. You basically just throw it into a cloud, and what you pull out, well, it's not truly random. True randomness doesn't exist for our purposes. For you and I, it's random. Don't worry about it. And you can set them, you can ask if they're equal to each other. You can say, is something inside of it? So you can say, is 4 in even nums, and it'll return true. You can put whatever object you want in it. You can make things an empty, you can make an empty set right here like this. Yeah, if you want to initialize any of these, right? So if you want to initialize, then you do use, like I was explaining, you can do list, you can do that. So you can do like, oh, it's the right size. So if you want to make an empty list, you can say list B, you can just do list and like this. Of course, you should probably do this because people know the square brackets as being that. But I think I'm pretty sure list will work. This will work, but I would just do square brackets. I'm pretty sure this will work as well, but you can also just do tuple. So tuple A equals. This will work. This will give you an empty tuple. You don't want an empty tuple, but you can make an empty tuple. Empty tuples don't do anything. It's basically useless. That's not entirely true. If you're adding stuff to tuples for a list, I mean, I would just add it to a list and then convert that list to a tuple instead of adding it to a tuple really complicatedly. If you're gonna add a bunch of stuff to something, just use a list or a dictionary if that's better, and then convert to a tuple if you want it to be a tuple, if you want to output as a tuple. So type tells you what something is. So type of a string. So if A, that will give you character. It's not character. It will give you string. And if we have a number, 25, that will give you integer. But if you do type of a list, then it will give you something more along the line of, so it'll give you class and then it would give you list. And in this case, this is a set. These are sets. So it says class set. But yeah, it's a little bit more complicated, but it's type just tells you what something is. If you don't know the name for something, you can use that, I guess. If you remember, I never remember. I'm always like, oh, what do I call it? It's gonna be class set. They are data structures. Tons of stuff have a ton of different names, but you don't really need them. These names, I don't think these aren't knowledge. Like our exams aren't just like, how do you use tuples? Explain every single thing you could do with it. It's not gonna be like that. It's gonna be like, use a tuple to do this thing. That's what's gonna be. And so how we are going to be using a tuple here is much more indicative rather than just knowing all this trivia about it. Trivia is not important. Knowing how to use it is. So here's some methods you can use with them. So you have set dot, like I was talking about, like you have dot append for lists, you have dot add for sets. They're all different. So actually, sets are a little bit like dictionaries. Actually, they're a little bit like dictionaries in that. All right, okay. So if convertible, we have I don't know what the word for it is, but let's say singular, non-singular. So your dictionary can only have. So we have dict a equals. Was it? I don't remember off the top of my head how to do addition. It was this. It was this, and we have this in the middle, and then we have that there. We have a. We have one. Your dictionary can only have one key called a as a string. It can only have a singular a as a key. You can have as many values. It can be whatever you want, but you can only have a single a key. And that's the same thing with sets. If you make a set, go ahead and make a set. Set a equals and to the yep, a b, just a b for now. You can only have one a, you only have one b. And set and dict are similar in this way, except dict you can have whatever values you want. So but that's something special about sets. They are singular. If you put 100, if you do set and you do dot add 100. So we have our set dot add, and you just put in 100. You can do this as many times as you want, you know, I'm not doing it very well here, but you can do it as many times as you want. But if you go and you go for loop, object in set, and you print out all of them, you'll only get a single 100 because you can only have a single every object you only have once, which is really good for checking if something is somewhere. So I mean, you can just do in, but whatever. If you have like a really like X dimensional list and you have something that goes through and you add all of it to a set, and then you can just say in. So a way this is valuable is you could have a list and it's some stupidly long multi-dimensional, go in here, and then you go inside. Yeah, if you have like something like this, and it can be. I don't know if in would work or if you'd have to specify the level, but if you were to get a for loop, you had your nested for loop, you had four, and then I think you need 1, 2, 3, yeah, something like this. And then here you'd have your set and you'd have lists. You'd have the object. You have the a equals, or no, you have set dot add, yeah, dot add, and you have a. And then if this was a repeat, it wouldn't do anything. But if it was new, you can get that new thing. And then over here you could say if 23 is, or in not is in set, and then you would know if something is in there. But I'm just not sure. I don't know if in checks each one of these or just the top layer. I don't think that's super important. If it is important, I can just use the for loop, but this is something you can do. This is a way you can use it. Just thinking about it. So yeah, but here's all the methods. You should have add, remove, discard. Okay. So the difference between remove and discard is just that discard removes it if it's there, and remove removes it, but errors if it's not. Just use discard. It's just better. It won't break. Update adds all elements from sequence to the set. Okay. So if you have a list, you can put a list here, and then all the objects in the list will go into the set. And then clear, it just deletes everything in the set. You could just do like, you could just have the set and you could equal it to something, just equal an empty set. So I don't know. Doesn't seem very useful, but sure. So yeah, you have the in operator. If you don't know what in does, I really forgot. I'm trying to explain to somebody who doesn't know anything. So we have our project, right? If 6 in project, this will return true. This will, or no, sorry, this would return false. This returns false because 6 is not in it. But if 6 was in project, it would return a true. In is a logic operator, and what that means is you can put it in if statements and it does something. And what that does in this particular case is you're basically saying if 6 is inside of project, then return true. If 6 is not inside a project, return false. So in is just really useful. So if you have a really long list and you don't want to print out and look at it because it's like 1,000 characters long or 1,000 objects long, you can say if in your object you're looking for in, and you can check. So very useful. And then just iterate loop. Yeah, and you can iterate just to for and I in range. You can't do this, right? So like I said, it's non-indexable. Non-indexable, it's not ordered, but it is, you can just, for things in the set, you just say element, and then you can just print it out, use it, whatever, so on. So that's sets and tuples. So like we said, so tuples, let's just go over them so far. Lists are ordered, they're mutable, they're indexable, they're iterable, they're convertible, and they're non-singular. So you can change them without having to do some shenanigans. They are indexed, so when you say list in square bracket 0, it will go to the first one. So you can do that. It's iterable. So if you put into for loops, you can do for lists for elements. It's a good word because I think object might be a special word, so you can't use it. But in list B, you can do this with it. You can go through it in this. You can pull from it like that. It's convertible. So if you have your list B, you can do set, and this will now become a set. It will lose its index. It will lose its order, but it will be singular. Whereas lists, so singular or non-singular means that I can have a list, which would be, and it can have one in it an infinite amount of times, and that's fine. Whereas with sets and dictionary keys, you can only have a singular version of it. Tuples, again, tuples are non-mutable, so you cannot change them. You can by just equaling them to themselves. So you can always just do tuple underscore b equals tuple underscore b 5, right? You can always iterate, you can always change them by doing something like this, but can we do this specifically? I actually don't remember off the top of my head. We'll get to set operations just a second. I'd make sure the tuples. So tuple. I mean, what you can do, like if you're not sure, you just do list. You can just change it to a list. It's convertible. You just do this, and then it would be dot append 5, right? And then you change it back to a tuple, and you do this, and then you'd have your tuple with your 5 in there. And if you're ever not sure exactly how to use, if you're ever not sure about the operators in tuples or sets, you can just convert them to lists and just use the list operators. That's one thing that's really nice about one-dimensional lists. If you don't know how to use it, you can just convert it to a list. You can just do list in quotation marks equals, your thing. You can keep it in the same variable, and then you can just do whatever with it using list operators. List operators. What is it called? Whatever. You know what I'm talking about. Methods. Yeah, I think it's list methods. You can only just use list methods. You can just convert it to a list, use list methods, and then convert it back. Tuples are ordered, and when you convert it to a list, it keeps its order, it keeps its index, so you don't lose anything. If you ever convert something to a set or from a set, if you convert something from a set to a list, you're not gaining, you're technically gaining data, but it just goes away. It doesn't matter. But if you try and add multiple of the same object to a set or to a list, and then you turn it to a set, you're going to lose. So if you convert anything to a set, you're going to lose non-singularity. You're going to lose iterability, or you're not going to lose iterability. You're going to lose indexable and orderable. And whenever you convert something to a tuple, you technically lose mutability, but like I'm showing you here, you can just convert it to a list and then back to a tuple. This is a one-line operation, not very complicated. It's pretty simple. So yeah. So that's tuples, and then sets finally are mutable. You can change any value in them. They're not ordered. They're not indexable. They are iterable. So if you put them in a for loop, they will work. Convert it, and it's non-singular. Or it's singular. It's spelled wrong. It's singular. So you can only have one of each. Tuples, unless they're non-singular. I misspoke. Yeah, history thing. So that's those three which we've gone over so far. Tuples, sets. Okay, now we're gonna do dictionaries. It's time for dictionaries. Yay. What was it? 18? No, maybe it's 17. I think it might be 17. Drink some tea. Nope, 16. I always wear myself out whenever I do this sort of thing. I kill my voice talking for hours straight. Ugh. Right. So finally, it's dictionaries. This is our last data structure we're going to be looking at. I think, yes. Yeah. Last data structure we're going to look at. So we have dictionaries, and they are going to be like so. Just put it right here. And they are going to be like this. They have the same thing. They're using curly braces, just like sets, but they have this double object thing. They have a colon in between two objects before they have a one. Before they have this comma. So this will have object comma object. This one will also have object comma object. This is when you're instantiating in the set. You make it like this because we have this is a computer. We can't actually tell it something without putting in order, but it won't be in order once you actually have it in there. Same thing with system one. But all of these, it's like this. These are separate objects, but in dictionaries, you have this much more complicated object called a key value pair. Now we're finally going to get to this. And its objects are basically two objects. You have a key, you have a value, and they form a key value pair. I know, I'm saying this a lot. And they're a bit different from lists. Oh, we're just going over this again. We can go back over this just to make sure I didn't miss anything, but not right now. Where are dictionaries? Come on. Let's review. 21. Oh, here we go. Here we go. So key value pairs. So I can't honestly, I'm not gonna lie, other than like dictionary phone book and like my email and password or my username and password, I can't really think of any key value pairs, but I'm tired, so I'm not a good example. Key value pairs are useful in a lot of different scenarios, a lot of different cases, but you do want to be careful when you're using. And very often, you're going to have key value pairs that are nested, or rather multidimensional, nested multidimensional. Because what you're going to do is you're going to have your key, which is just this single string. It's usually a string, but then your value, you're going to have it be a list. And so the way you'd call it like this. So you'd have dict underscore b, and then you'd have your key. So you called your key. So let's say your key is, right, key's happy. And then the value is a list. It's not an object. It's not like a string or an integer. It's a list. And so if you just have this, this is now equal to, if you set this equal to, give your list in this way, happy people or something, whatever. Happy people would now become a list. It would become a list, and become a list equal to, this, for example. But if you just want it to equal one of the objects in the list, if you want to equal this 80 here, sure, then you need to specify object, the index of that list. So something to keep in mind. When you will probably at some point we'll probably use this. This is something we'll probably use, is having dictionaries where our values are our lists. This is pretty likely to happen at some point. And here we can show. So notice how we have 1, 2, 3, 4, 5. So we have 6 objects, 6 distinct objects, different orders and classifications, and all that. But if we do length, it's 2. So when you do length of dictionaries, this key value pair and everything in it is 1. This is 1 length, and this is 2 length. But while you can get its length, they're not indexable. So if you do this, right? So we only have, let's say our dict underscore b only has a single thing in it. If you do 0, it's not going to work. It's not indexable. Other than that, it functions a lot like just a regular list otherwise. So it's mutable. You can change everything. I'm not sure. I don't think you can change keys by just like deleting them and re-adding them with the change key, but I'm not sure you can actually change them otherwise. They might be immutable without deleting them. I'm not sure of that. They are ordered, not indexable. They are iterable. So if you put this into a for loop, it'll just print out the key value pair. They're convertible. If you do so for example, if we did list, this would give us, and this is only has happy in it, like we're talking about. This would just give us, this would turn into a list with one object in it. It would turn to happy, and it would ignore the value. I don't know exactly how to convert dictionaries where it gets both the key and the value. I think you'd have to go through a for loop to do that. This will only grab the key. It will not grab the value. So just something to be aware of. So that's length. It's indexing. Exit individual values. The key index does not so technically it has an index, which is its key. It is indexed, but it doesn't have positional indexing. It doesn't have 0, 1, 2, 3, 4, 5, 6, and so on. But like I said, dicts are ordered though, which is a little bit funky, honestly. I feel like dictionaries should just allow for you to like. I don't feel like there's any reason. Like I don't feel like there's any reason that you couldn't just have like, for example, dict to B, like the underscore B, and just say 0 and just be the first object in there. I don't see why that. Like, I'm sure there's some reason, like maybe it opens up a vulnerability or something, but I just don't see a reason that this wouldn't just work because it's not a string or it's not a list. So it knows you're just looking for the first value. And like, I don't know. I don't know. It could be because this isn't clear on whether you're accessing the key or value. I assume you just want to get the value with this sort of thing, but I don't know. That's yeah, there's a problem. It's not clear whether you're looking for the key or the value, but whatever. The way you work with it in a for loop is you do for key in underscore b, and what this gives you is this gives you the key, and then down here when you're working in it, you'll be doing dict underscore b, and yeah, and you'll do this. Oh, that's why I forgot. Sorry, I for some reason I thought that it did like this, like these were curly braces, but they're not. So I'm stupid. Whatever. Never mind. That was dumb of me. Anyway, so this is where you put your key, and this is key in there, and then this would equal. This would be your value. You get your value from this. So if you want to get both your key and value, then you could have key underscore list and value underscore list. So we're just ripping it out of dictionary. So we'd have no. So we have dig, and this would be value underscore list. Would be dot append. So this would give us our values, and then we could just have key underscore list dot append, and it would just be the key. So this would be how if you wanted to pull all the keys and values out of a dictionary to two lists, you could do this, and they would be in the same order. So you'd have your key, and it would be at the same index as its value. So you wouldn't lose anything doing this, but you would have to do a for loop. So that would take time and code that you don't want to use otherwise. So yeah. So yeah, indexing. So it's not too complicated. I don't think it's basically just a call. This is just like a phone number. This is the phone number. This is the person you're calling. Not too complicated, I feel like, that's I don't know if that analogy is actually good or not, but that's how I think of it. I'm pretty bad with dictionaries, I'm not gonna lie. So I'm not sure why you'd use this instead of just doing this. I mean, it returns none if the key's not found instead of erroring out. So that's nice, I suppose. As a sequence of tuples. So here we go. So this is how you get all of them out. Sequence of tuples. Would this be a list of tuples or like I don't know, whatever. Not keys. So if you want to get all the keys out and like just get them in as a list, you can just do a list equals to dict.keys. I'm probably never gonna remember this. And then you can do this. So I was just telling you how to do it. They tell you how to do it right here. I'm probably not gonna remember this, but and they might take points off, but whatever. I'm never gonna be perfect. I'm never gonna remember all this. I'm just not that sort of person. And then dot clear. Once again, I don't really see the point of this when you can just set it equal to nothing, which clears it anyway, but I'm sure there's some, oh, well, if you clear it, or if you don't dot clear, then it will actually still be in there. And then if someone grabs your RAM and then it's still in your RAM, whatever. I'm sure there's a reason, but I don't know it, and it doesn't matter to me. Yeah, I'm pretty sure you can just yeah, you could just do this. I don't see the point of dot get. It doesn't make me, I know there's some reason, I'm sure, but it's completely meaningless to me. It means nothing. And then she does some practice problems working with them, which are nice, teaching us things. Very cool. Okay, so that's dictionaries. They're not too complicated. They're pretty simple. You just do dictionary, the name of your dictionary equals to, and then in curly braces, you do value, comma, not value, colon, value, colon, value, colon, value. And you have your key, which is the phone number or the reference or the index. It's the index technically, but whatever. The thing, the way you call something, and then the thing you're calling. The value is the data that you're going to change. If you're working with dictionaries, that's what you need to know. Is that your key is how you access the data. The value is the data you're accessing. You're going to be changing your index very often, probably, if you're working with the dictionary. Maybe you aren't, maybe you're just, I don't know if we're actually going to be changing them, but if you are changing them, you're going to want the value that changes to be the value. And you're going to want the value that doesn't change, that references, that tells you what you're looking at, to be the index, the key. So that's dictionaries. I guess we should go over this. They're mutable. They are ordered. They're not numerically indexed. They are key indexed. Just whatever. They are iterable. They're convertible very easily. Dot key. I don't have it open anymore, but it's dot key and dot value will give you a list of them. And they are singular. The key is singular, right? So we have this one here. We can never have another key just be one. We have to use something else. It has to have something else in it that changes it. But the value is non-singular. The value can be anything, and we can have the exact same value a million times. It just doesn't matter. So that's dictionaries. You can go back over the slides if you want to. I believe did we use a dictionary in number 6? I don't remember. We might use a dictionary number 6. I don't know. Finally, we're going to get to files. So opening and using stuff that's in files is really important, and we're probably only going to use it more. We're probably I think the last 2 assignments we had, we opened a file. I'm pretty sure we're gonna do it for every single homework from now on. It's probably, I don't know that they're going to have it on the exam, but they might. So it's just something you're gonna need to know how to do it. It's pretty important. Data structures, yeah. What's what lists and all these other things are. We just store organized data. Man, that's so cool. Anywho, so lists, tuples, sets, dictionaries. When do we get to files? Here we go. So if you're doing ML, you're doing machine learning, AI stuff, you're going to be reading a lot of .csv files. If you're doing data processing, probably also a lot of CSV files. If you're doing statistics, probably also a lot of CSV files. I know we're not going to be using .txt files pretty much exclusively. I would be very surprised if she had us get a .csv file, because most people are not going to know what that is. But CSV files are probably easier to use, in my opinion, but that's not important. Yeah, so the way we open files is really simple. We do our name for the thing that's going to shove the file in or pull from the file or whatever. It's going to influence. No, never mind. I'm not going to make fun of it because I'm going to confuse someone. I'm sorry. So we just say open. So open as opposed to close. So we'll say something. When you're done with it, you're going to want to close it. It explains that there's something RAM, the opening problems. Don't worry about it. Just close it once you're done with it. If you open a file, just remember to close it. That's it. Like, I'm sure there's really important reasons, and it's like really bad if you don't. I don't care. Just close it at some point. Just do it for the grade. We're in a class. We're getting a grade. Let's not kid ourselves here. We don't actually care. uh, I'm sorry. I'm joking mostly. So you open, and this will be your file name. So that's why we have. So if we go to here, so as you can see, we have homework 6 starter. I didn't actually do my homework 5 on this computer on my laptop, so it's not here. But as we can see, they're in the same thing. If they were in a different folder, then you'd have to file path it. You'd have to tell your computer exactly where it is, and that can be really annoying. So whenever you're doing this sort of thing, you're just going to have it in the same folder and not have to worry about it. It can be very annoying. The file path can just be really annoying to deal with. And then the mode is there's 3 different modes. You have read, which is to say you're going to read from the file. You're going to pull data from the file. Write means that the file doesn't necessarily mean it's empty, but you're basically treating it like an empty file. You're just going to start writing stuff to it. If there's something there, it's going to get deleted. So only do that to empty files. And then append is what you do for files that currently have something in it. You want to add something to it. You do dot, you do a, you put a there, and then what you put in will add stuff to it. I don't think we actually use append. I don't know. Can I control F this stuff? Let's see. Okay, so we can control F this some of it. So we do a there and open the file. So this is talking. I just want to look at it because I don't actually remember this very well. Preserves the existing file as it to the end of the file. Can write to a file. So okay. So when you want to write something to a file, you'll literally just have this is the name of the file, the variable that you plugged it into, dot write, and then you're just gonna plug something in there. I don't think we'll use this on the test. It might just be something to think about. Just like we might use this, probably won't though. So, and then not closing the file after write, maybe lots of points more like it. Haha, just kidding. But yeah, so open file, close file, and then W, it's just the same thing as A apparently, just write to it. You must close it, close the file. And then when you read from it, the way you read from, so you're not usually, when you're reading from files, well, the way you're going to do it, 90% of the time, is you're going to do, your file variable dot read line. You're going to do read line, and you're going to put in a for loop, and it's going to read every line. Or, more accurately, you're going to do, we actually just did this, so I can just pull it up. Here we go. It was in homework 6. Wasn't it homework 6? Yeah. So here we can see I opened the file, and I just named it file. I know, really creative. My creativity is simply unbounding. And then I said for line in file. Now what this does is it just grabs line by line. This is how you're going to do it most of the time. You're either going to do it like this, or if you're doing a while loop, you're going to do read line. You can do read lines. I wouldn't do that. Just because it returns a list of strings, and you can. It works the exact same way. It's not actually going to be very different, but I usually want to do something like this, just to not have an intermediary. It's just easier, I think, to just do something like this or like this. I can't think of off the top of my head a reason to use this, but I'm sure there is one. Maybe you want to put in like a tuple. Maybe you just want to have all of that in a variable, and you're not going to do anything to it. You're just going to read from it. Excuse me. This is going to end soon, so I want to finish this up. Is there anything else in here? That's not file stuff. Exceptions. I don't think we actually are going to use exceptions, so I wouldn't really worry about it too much. See if I can find exception. So basically, the whole thing with exceptions is that you don't want errors to break your program. So what you're going to do is you're going to do try, and then you're going to do except. And the simple thing is that try is going to do something, and then if it doesn't work, then it's going to do except. That's from what I understand. Try to try an exception. So it's basically just an if else kind of. If it's like saying if no error this, if error this. It's kind of how it works out there. If it is, I don't what I'm wondering is what happens if your accept errors out? Does it just break your program? I mean, erroring out breaks your program. So doesn't look like I talk about that. I don't think it matters. Yeah, so the reason you're going to use this is if you have an input, say you have like I was talking about my not this one. So here, so we're asking them for their bank account. And this is supposed to be a list of numbers, right? It's supposed to be like 0, 0, 0, 0, 1, 1, 1, whatever. A list of numbers. But let's say they put a string in it because they're just slamming their face on the keyboard, right? That won't work. And when you send that list of, that string to your fetch bank details, your program is going to throw up on itself and break. So what you would do is you would do try, and then you'd have this, and you'd have try, and then you'd call this, and then you have accept, and then it would print out, please enter a valid bank account number. That's so that's what we would do is we literally just do this. So we'd have try and this, and then accept, and then we'd have print. That was not a valid account number. And then we'd and then say this is a loop. This would loop back, and it would then ask bank account, enter your bank account number. And people can just keep giving non-accurate, not real bank account. They can just do it over and over. It doesn't matter. That's the whole point of try and accept. Of course, you can do it. This isn't. There's a lot of ways to deal with this sort of thing, which is called data handling, data transformation, error handling. There's a lot of different words for it, and they do mean different things. But basically, it just means when you're getting information and you're getting data in, if it's not good and your program can't do anything with it, or it breaks your program, you don't want to put it through your program and break your program. So instead, you can have if, like I have in my homework 6, if character is not in. So basically, this is saying if our character is a alphabetical character and not punctuation. I could have just done if char is alphabetical, whatever. I'm just realizing that now, but that doesn't matter. Anyway, so if it's alphabetical, then it will go in here. This is basically data transformation, data handling, error handling, whatever. Because if I put one of these in here, well, that's not a word. That's a word with punctuation. We don't want the punctuation. That would throw an error when I try and turn it in, and I won't get the grade that I want, which is 100, of course. So in order to fix that, we have this to clean our data. This whole thing is cleaning data, but whatever. We also have this, so none of these can be in our data either. So you can use try and accept. You can do this, right? This is valid, and you probably will use it at some point. We'll probably have an assignment that tells us to use it. But for now, usually you can get away with not using it and just having an if-else statement. So if string not alphabetical or not numerical, then and then we have print, this is not valuable. You cannot enter this, and you'll have something else. So I have a online game tournament to get to. So we'll get to string methods, exceptions, and modules later. And I'll go ahead and update this, or upload this, and then I'll either stream it. No one's really showing up. I have no idea why, but that's all right. I don't really care. I'm doing this to help people. If they don't come, they can watch. I know some people don't like to. I ramble a lot. They might want to skip through a video. Let TikTok brain. I'm just joking. I know this is a little bit dry, but I'll get to exception to modules. All right, modules. I didn't do string methods. Okay, I need to get the string methods. String methods and modules next. And then I'll go a little bit more in depth on all of them, but I think that'll be all for now. So if you only watch this, or only watch the first 2, then I wish you luck on your exam, and I hope you do great, and I'll see you later.